Hoover Dam Secrets, the hidden engineering marvel that changed history. Behind the simple appearance of the exhibition rooms inside the Hoover Dam lies an important secret that, if missing, could lead to disaster. Have you ever wondered why the design engineer, John Savage, left a 6-foot gap between the body of the dam? A strange decision, yet it was the key factor that allowed the dam to stand strong. Without this gap, the concrete would crack within just a few weeks. Was this a stroke of genius or a risky gamble? Let's explore the secrets behind these bold decisions. Don't forget to like, subscribe, and hit the notification bell to follow more fascinating discoveries. The construction of Hoover Dam began right on the Colorado River, a river so powerful that nothing could be built on it without controlling its flow. So how could the American engineers tame this fierce river? According to some reports, the only solution was to divert the river. To achieve this, they built 4 massive tunnels, allowing the river to flow through without affecting the construction site. However, this was no easy task. The engineers created a gigantic drilling machine, capable of holding up to 30 drills to create holes for dynamite. This controlled explosion helped dig tunnels through the rock, but that was just the first step. After the explosion, workers had to carefully clean up the debris, and instead of discarding the rocks, they reused them for future work. But right after that, they faced the next huge challenge: pouring concrete to stabilize the tunnel, which wasn't simple when dealing with massive rock formations. Behind these bold decisions is a series of mysteries and great engineering techniques that helped Hoover Dam become an awe-inspiring engineering marvel. However, the initial method of pouring concrete could not be applied to the rest of the tunnels. To solve this problem, the workers began installing reinforcing bars into the rock, linking them by spraying concrete into the gaps. But an interesting thing happened. To pour concrete into the sides of the tunnels, a special shaping machine was used. This hydraulic machine could expand after entering the tunnel, allowing precise concrete pouring into hard-to-reach areas. For the top part, workers used a pneumatic concrete gun to finish the job. After the concrete was poured, the shaping machine was removed, and at this point, the giant drill resumed its work, drilling even deeper. This process was repeated several times, and after 18 months of tireless work, the 4 guiding tunnels were completed. However, one question arises. If trucks start dumping rocks and dirt upstream, how will the water level rise? The engineers knew that this could pose a danger to the construction site, as the piles of rocks and dirt were increasing the height of the mountain, causing it to surpass the top of the tunnels. Therefore, they had to act quickly and completely divert the river. To ensure that the water wouldn't seep into the construction area, they built temporary dams, called cofferdams, which helped block the water and keep the site dry. Successfully diverting the river provided a safe working space, allowing the engineers to continue their work without interruption. The tunnels were used to construct the cofferdams, keeping water inside the riverbed, while the Hoover Dam project proceeded without obstacles. When they began building the Hoover Dam, the big question was, how could they ensure the dam wouldn't collapse under the immense pressure of the water? The engineers realized the dam needed strong support from 3 sides. To achieve this, they started by removing the weak weathered rocks surrounding the site, then cutting deep into 2 mountains to form the exact shape of the dam's body. To do this, they had to use dynamite and drills to break apart the rock at the base of the dam, drilling 300 feet deep to reach the solid layer of rock. Once the site was prepared, they began pouring concrete block by block, allowing the heat to dissipate and preventing cracking, while also creating space for the cooling system inside. When the concrete blocks had hardened, they were filled with concrete slurry to bond them tightly together, creating a strong structure. The asymmetry in how the blocks were arranged ensured that the dam could withstand the massive pressure from the water. And the top of the dam, once completed, was wide enough to accommodate a road, clear evidence of the grandeur of this project. To pour concrete quickly and efficiently, the Hoover Dam engineers invented a special mechanism. Initially, the concrete bucket was placed on the floor, and when the worker released the PA lock, the bucket would automatically open via a hinge mechanism, pouring the concrete precisely and swiftly. After that, the workers closed the water tunnels and dismantled the cofferdams. As the water level rose, a new question arose. Could the dam withstand the pressure from the massive amount of water? According to information gathered, to reduce the effects of uplift, the engineers designed special drainage chambers. These drainage holes, filled with mortar, would absorb leaking water from the dam's foundation and significantly reduce hydrostatic pressure, helping to maintain stability. This is a simple yet highly effective technology. Next, we move on to the most important part: how Hoover Dam generates electricity. In the U-shaped power plant, 17 giant Francis turbines and generators were installed. Water flows through a spiral casing, spinning the blades and generating power. These turbines do not use permanent magnets, but instead use electricity from an exciter to create a magnetic field, converting the energy from the water into electricity. With the system of unusual towers and pulley cables, the installation of these generators was a monumental task. This structure helped move and position the giant generators accurately. These technologies turned the Hoover Dam into an engineering marvel, proving the limitless creativity of the engineers of that era. To install heavy equipment, such as generators and turbines, the workers used a special lifting mechanism consisting of 3 cable drums held within a winch. According to reports, this cable system passed through a clever pulley, allowing large equipment to be moved into place precisely. This miraculous solution has been used since the time of the Hoover Dam and continues to be used today. Once the materials were transported, a large gantry crane was used to assemble and install components like the rotor and stator. But the next question remains: how was the water from the reservoir transferred to the turbines? It is said that the engineers designed a system of water intake towers, which helped guide water from the reservoir into the tunnels beneath the dam. However, not all of the intake towers had pre-existing tunnels, so they had to build new water conduits with a steel lining to prevent erosion over time. Another important part was the spillways. If the water level in the dam exceeded the limit, the water would overflow, potentially endangering the downstream facilities. To address this, the engineers designed spillways 27 feet below the top of the dam. These spillways have a rotating mechanism, allowing the dam to store more water when necessary. As the water level rises, the spillway structure rotates, controlling the release of water downstream. After 5 years of intense construction, the Hoover Dam was finally ready to hold water. Removing the temporary cofferdams was a major challenge. The engineers created controlled openings to allow the river to erode, thereby removing the temporary structures. After a small explosion to break up the materials, in August 1935, the cofferdams were removed and the water began to rise. A month after the inauguration ceremony, the public was amazed by the sight of the massive reservoir. However, it wasn't until October 1936 that the first generator was installed and operational, and it wasn't until 1961 that the full 280 megawatt capacity of the dam was reached. Notably, today, solar power plants can generate the equivalent of 2,000 megawatts, more than 7 times the Hoover Dam's capacity. The Hoover Dam, with its groundbreaking technologies and innovations, is not only a great engineering feat, but also a testament to the strength and intelligence that overcame all challenges. If you find mysteries like this fascinating, don't forget to like, subscribe, and hit the notification bell to explore more intriguing discoveries with us. Thank you for watching, and see you in the next exciting exploration video.